Welcome to the Pro Tips video series designed to arm biology learners with background knowledge needed to succeed during upcoming lessons. I'm Professor Workman, and this video continues our discussion of chemistry. All previous chemistry lessons were leading up to this. Hydrogen bonds allow life to exist, so let's learn about them. A hydrogen bond is an attraction between the partial positive hydrogen on one side of a polar molecule to any nearby negative charge. It is therefore a type of bond that only polar molecules can instigate. Imagine this hydrogen using a sci-fi locator ray gun scanning the area for nearby negative charges. If found, it beams them in like a north magnet pulls a south magnet until they connect. This hydrogen is employing a ray gun of its own simultaneously. Once formed, hydrogen bonds are both organizing and disruptive. Let me explain what I mean. Hydrogen bonds influence the orientation of polar molecules in three-dimensional space. To demonstrate, we start with a polar molecule that has at least one hydrogen carrying a partial positive charge. That is the prerequisite for hydrogen bonds because, as their name suggests, it's hydrogen that is going to make the bond. So imagine putting a bunch of water molecules together. They have an instant problem because the partial positive charge on neighboring hydrogens repels each other. Oxygens don't get along either because their matching partial negative charges repel. The solution is for some of these molecules to spin around so that their dipoles align head to toe. By head to toe, I mean positive to negative. This is what those same 9 molecules could look like in your glass of water or a droplet of rain. Hydrogen bonds are often drawn as dashed lines, like I've done here in light blue. Notice that they connect the positive end of the polar molecule, that's the hydrogen, to the negative end of its neighbor, that's the oxygen. Notice also that each water molecule can hydrogen bond to many others. Unlike ionic and covalent bonding that requires an accounting of electrons, hydrogen bonds simply align like magnets, and this happens naturally without any energy input. Polar molecules spin around and line up head to toe the same way you might have watched magnets do. Hydrogen bonds makes water sticky because each molecule is connected to potentially every neighbor in all directions. The water molecules stick to each other, that's called cohesion, but they also stick to anything with a negative or partial negative charge. When water sticks to something that isn't another water molecule, that's called adhesion. The dewdrop in this photo adheres to the leaf. This dewdrop resists gravity because it is hydrogen bonded to the underside of the leaf. Hydrogen bonds are also disruptive. They break ionic bonds, causing ionic compounds to dissociate, which means to separate into its component ions. Let's see how this works. Sodium chloride, or NaCl for short, is table salt. Surprise, fancy name, just tasty salt. Have you ever put salt in water? I do this when making pasta sometimes, so the water in my pasta pot is arranged with hydrogen bonds. Then I add salt. And what happens is the water molecules reshuffle their hydrogen bonds to accommodate the salt. The positive end of the polar molecule, that's the hydrogen, remember, orients towards the negative chlorine ion. If there are enough water molecules, they completely surround every chlorine ion and the salt becomes dissolved. So hydrogen bonds break ionic bonds, and those hydrogens surround the negative ion, causing the ionic compound to dissociate. In this example of table salt, it leaves that sodium positively charged ion to float around on its own. It could interact with the oxygen end of the water molecules, but that's not a hydrogen bond. In summary, you learned that hydrogen bonds are attractions between the partial positive charge on the hydrogens in a polar molecule to anything negative. You learned that hydrogen bonds connect. For example, they make water sticky. You learned that hydrogen bonds organize. They influence the orientation of polar molecules. And you learned that hydrogen bonds disrupt by breaking ionic bonds. Thanks for watching. If you liked this video, you might consider watching other videos in the series. Here's my contact information, and I always welcome any feedback. mworkman@pima.edu. Good luck in your biology journey.